Hi, today I want to get back into hardware and start looking at the program counter. The goal is to try to bodge the PCB and try to get it to work the way it is in software. Now, my problems were related to load increment and decrement being multiplexed, and I'm going to have to undo that. And that means I'm also going to have to extend additional signals into that PCB and add some additional logic in order to shape the control signals a little bit. I've got about 12% of a plan. Let's get into it.
Hi, I'm Adam. I'm still building a 16-bit computer from scratch. I'm no expert here. I make lots of mistakes. So many mistakes I've actually had to reboot my computer build. I hope you will find my journey interesting, and I hope you will join me as I learn along the way.
Okay, I think I'm going to start with the schematic for the current register, general purpose register PCB, and see if I can't explain exactly where my problems are in hardware. Now recall that my first problem started with my decisions related to the load increment and decrement, where load really needed to be shaped differently, the signal I'm talking about. So the load signal needed to be shaped differently and have different timing than increment and decrement did. And not realizing that, but then making decisions around that really created the problems that caused me to have to take a huge step back and relook at a number of these things. And those relate to the two signals here coming in, which are multiplexed register change actions. I guess is probably the best way I can describe that. So I have an input 0 and an input 1, both of them coming in through control signals here, which are going to this pad here on a 74HC138 demultiplexer and this pad here on that same. So throwing a pin diagram up on the screen, these are the input selects. C is here, but it's tied to ground. So my input A, input B, input C, which means I get one of 4 different pins set high. Now this could be pin 15 up here, which was do nothing, pin 14, which is my load signal, pin 13, which is my increment signal, and pin 12, which is my decrement signal. Okay, that's current state. So what do I need to do? Well, all 3 of those signals now need to be handled and shaped independently, rather than using a demultiplexer like this. Which means that these 74HC138 really needs to go away, and I need to connect to load, increment, decrement. These pads can be my connection point, the 3 signals that come from pins 2 and 3. Whoa, wait a minute. 3 signals off of 2 pins, yeah, well, we're talking about the program counter here. So decrement really has no place in a program counter. I certainly have never seen a program counter that wants to decrement. I've seen a stack that wants to decrement, but not a program counter. So for the purposes of my tests here, I'm going to ignore decrement, which means that what I can do is I can designate one of these pins, and I'll just take pin 2, for example, as an example. I can take that pin and designate it to be a load pin, and I can take pin 3 and designate that to be an increment pin. And then I can take those 2 signals, pipe them directly into pin 2 and pin 3, and totally take the decrement out of the picture, totally take this demultiplexer out of the picture. And then if I do that, then my load signal will end up here on pin 1, and I should then be able to take a Bodge wire and go from pin 1 to pin 14 after removing the 138 demultiplexer. Similarly with increment coming in on pin 3, I should be able to, it's already extended over here to pin 2 on the 74HC138. After removing that, I should be able to take a Bodge wire and connect pin 2 up here to pin 13 and have that continue to work. Now decrement is going to need to have its signal handled properly, and if I take that low by taking pin 12 and connecting it off here to pin 8, which is a ground ref, that should then completely drive that low and not leave that output floating. And that should be the extent of what I need to do in order to make this work, or at least the changes to the PCB. There are other changes that are going to be required, but we'll get to those here in a few minutes. All right, for this, let me get the hot air workstation up and running and get some Kapton tape out and see if I can't get this IC desoldered. Okay, the first order of business here is to protect the adjacent components, particularly these LEDs and probably this IC here. So I've got some Kapton tape I'm going to start dropping in place here. And I believe the proper protocol is to add flux. Well, that was less than graceful, but I've got it. Okay, I'm going to make an attempt to pull some of this solder off. Just make sure that it's as clean as possible. Okay, let me go clean this up. Now, if I'm to understand from Mr. Solderfix, the more time I spend actually prepping before I grab the soldering iron, the better this is going to end up. Now, if you haven't seen any of his videos, go check them out. I'll leave a link in the description, a card up in the corner. Let them know I sent you. I'm going to be using this 30 gauge wire wrap wire for this. And to scale here, it looks positively massive, but it is, I guarantee you, very tiny and going to be very fussy to deal with, especially given the small size wires, small length wires that I'm going to be dealing with. I'm not exactly sure which one I want to start with, but I do know I have to start with stripping this wire, which in and of itself is going to be a challenge. I'm not exactly certain how I'm going to make that happen. And I actually did it with my flush trim, and I'm just going to give myself a length of wire here, because what I now have to do is get this fitted into position where I'm going to solder it. That did not work. This is a piece of solder. Let's give this a shot and see if I can't get this twisted into place here. Okay, so this has to go to that pin and then get twisted down here. I know my finger's in the way. I can't see either. Okay, that looks, well, dare I say, somewhat reasonable. But I do have to flatten this out a little bit and trim it to length. Okay, so that should be roughly the size of the wire I'm looking, or the shape of the wire I'm looking for. Not necessarily the proper length of the wire, but if I cut something to roughly that size, I should be able to then strip it. Now let me see if I can get the ends trimmed properly here. But that looks like it's going to be a good length, so let's see what I can do with it. So here's the length of wire I need, and I'm going to straighten or flatten this back out again, roughly. And this is the length of wire I have. So the first thing I want to do is I want to try to cut or strip the insulation off here. See how well I can do with that. And trim that to rough length. Yeah, the question is did I score the wire when I cut the insulation? And I believe I did. Maybe a bit of a challenge, but I'm going to try stripping it with my X-Acto knife. Problem is I can't get through the insulation. That appears to have been the best attempt yet, and I know it was not on camera. But this is what I've ended up with. Now the next challenge is to get that cut to actual length. And this might be just a smidge short. That looks like it could work. No, two more like that. So this ended up being a process of cutting a wire to rough length, stripping the ends with an X-Acto knife, and then bending it into position using tweezers. I'm not going to say it worked really well. Well, in theory, that should be my bodge. Okay, so the next thing on the list to do is to fasten these down with Kapton tape. And I'm afraid that when I do that, they're going to move significantly. So we'll see how this works out. Yep, that's significant. All right, well, that's somewhat stuck down. Okay, next I'm going to use the flux pin and put some flux here. That bumped out of the way. And now as I wait for the soldering iron to warm up, I believe the plan here is going to be to get some solder on the tip and then just simply touch the wire and hope that it doesn't go anywhere. Because if it does go anywhere, it's going to be a pain to pull back into place. It'll likely be a scrap and start over type situation. Okay, so let's start with this one over here. Okay, well that gets them at least tacked into place. Although I'm not sure I like completely the positioning. But it gives me the ability to put some more solder, hold that down. Well, I don't know that it's going to win any awards, but it's done. With the bodge done, I now have to look at the signaling that comes into the program counter register and make sure that it's now correct against what I've got built out in the emulator and what I'm intending to order as part of the PCB. And so the signal shaping associated with the control signals is located here. Yeah, that's too small. So signals I've got coming in, I've got the clock coming in, which right now I don't have anything. I'll have to manufacture something. I've got the increment signal, which I'm going to use. Obviously, it's a program counter. But decrement, I'm not going to use. So this one here has been eliminated specifically for the program counter. I've got load, which is inverted. I've got reset, which is inverted. And I have to shape those signals as well. Each of the asserts out onto the bus, and remember there are 6, need to go through an inverter in order to get there. All right, so to shape these, I now have to introduce a NAND gate, or 3 out of 4 NAND gates off this IC, and all 6 inverters off of this IC in order to shape the signals. Here, I'll set it here. In order to shape the signals for the program counter in the way that I'm going to use that. Now, keep in mind, it's not a one-to-one test here. I have on the back, I believe those are these 2. I have 2, nope, those wouldn't be they. They would likely be either these 2 here or these 2 here. I just can't see them. Anyway, long story short, I have 2 latches here, and the rest of this is actually line drivers for asserting out on the bus. It was a simplification that allowed me to reduce the number of ICs on this printed circuit board and therefore reduce the signaling, I believe. But if I shape the signals correctly, the behavior of this board should match the behavior of my design here. And that's the intent that I'm going for here. So while it's not an exact test, I should be able to prove out that the signals themselves actually work. Well, how am I going to introduce these 2 ICs onto this PCB? Well, I'm not. So my plan here is to take the small breadboard and introduce the ICs here, and then take a ribbon cable and drop that into the register backplane so that now I can shape the signals on here and then turn around and have those pass off to the program counter. All right, so for this, I'm going to need bits of the build, and I'm going to need to pull those out. So I'm going to grab the register backplane off the build, and I'm going to grab the clock and reset circuit off the build, and we'll figure out what changes we need to make to those in order to tee this up for testing. Let me grab those components. Okay, I got the backplane pulled off the build and I put my program counter in it. I stuck it in the bottom because it was just easier to keep it in frame. And then here are the inverter and NAND gates that I'm going to use in order to do these hookups. Now my plan is to actually follow even the pinning on here. So my clock plus my increment signal, and then the output is on pin 3. So 1, 2, and 3. This would be wired over to where my increment signal would be. Now down here, I did print out one of the old labels that I have taped to the ribbon cables. And this hasn't been updated to reflect the new pinning related to the Bodge here. But I needed that to be able to identify what signals are actually where. And so the point is, or the intent is that the inputs will be down here, run through the signal shaping here, and then output out here. Now in my current control EE problem, these are multiplexed. I have 4 different things that are tied to 2 different signals. That's obviously going to have to change as well, which is why I'm not going to hook it up to the current control logic yet. All right, I've got power hooked up. I've got decoupling capacitors hooked up. I've got power and ground for the ICs. I've got the power rails jumped. You've seen me do all that a million times before. Okay, you don't need to listen to me narrate my way through this hookup wire by wire. Suffice it to say that I'm actually following the pin diagram that I have on the paper next to me and going through hooking this up and extending the outputs over to the ribbon cable, which will take those to the register backplane, which will then carry them to the register itself. That's 10 signals. I have eliminated 1, or temporarily eliminated 1. So that's 11 signals now coming into this register on a 10-pin hookup. So hold that thought, because when we get to the backplane redesign, and there is one coming, the register backplane will be changed to accommodate these signals now. So that's the basic hookup. Now if I take my increment signal and bring that high, and my address bus 1 signal and bring that high, those 2 changes alone should have this operate like a program counter, and with every clock cycle count up. All right, let me go extract my clock and we'll give that a test. Okay, you should recognize the clock circuit. Now there are changes that do need to be made, but I'm not prepared to take them on today. I turn it on, and I'm in single step mode here, and it's not incrementing. All right, so I've got load, increment, decrement, and latch. If you pay close attention, you see that both increment and decrement are lit, and decrement is always lit. And yeah, I made a mistake here with this Bodge. Let me bring up the document. Well, the challenge is that there's no truth table associated with this IC, but I do recall that when you're counting up, the down signal or the down pin needs to be held high, not low. And when you're counting down, the up signal needs to be held high, not low. And in my Bodge, I tied it to ground like a fool. So I'm going to have to get the soldering iron back out and see if I can't fashion a new Bodge wire that connects this to VCC or to some high signal that's close by, rather than tying it to ground. Okay, I'm having a bit of a battle with my digital microscope here, so bear with me if there's any trouble. But I tied this signal here to ground, and ultimately it really needs to be brought over here to VCC. And I believe the best course of action is going to be actually to remove it completely and start over. So let's see what I can do about that without making too big of a mess. Now I have to fashion a new wire, and that's going to involve stripping again. Well, stripping the wire. Okay, and here it is down here in the corner. And if anybody's got any suggestions as to how I might go about doing this a little bit better, let me know, because I will be honest, I'm struggling with this. So it needs to go there, and then I need to bring it. Looks like it's the right diameter. I'm wondering if I shouldn't just try to burn right through the insulation there. All right, let me shorten this up a little bit. Okay, so it should be just a matter of stripping this right about there. Yeah, this is turning into a mess, and this is the problem I had before. And then at this point, I just have to deal with my own shaking and nudge it into place. That's pretty close. Got a little bit of a tail here I got to deal with. Let's start with a bit of flux. And then see if I can't get this lined up better. Okay, there's one side. Not perfect, but we have just a touch more solder here. And I've got a pad that's got just a little bit of solder on it if I don't want. Well, I'm going to leave that as it is. I say it as I start fussing with it to try to straighten it out. Kind of makes me think I'm probably better off just using the heat to melt through the insulation. Enough of this. Let's get the build out and see if I've fixed my oops. Okay, let's put the program counter back in, apply some power, and see if we can't get an increment. Now, my decrement LED is now off, so that's good. Ah! I hate it when that happens. I really thought I had that figured out. The increment is happening, and latch is happening. Are they happening in phase? That's a good question. Well, I guess it wouldn't matter because it should still be latching. All right, let me grab the logic analyzer. So this should be clear as high. My reset signal should be active low. I've got that pulled low down here. Is it really that simple? Now, as I'm going through this, I'm looking for each next LED up in the chain to take twice as long as the previous one took. But overall, this is looking good. Well, I'm not going to lie. I am very happy to have the build back out and looking at LEDs rather than just on screen. The bodges that I put in place are not ideal. Obviously, they're bodges, but they're not even ideal in that the register doesn't truly match what I have built in the emulator and the schematic that I have put in place. So there is going to be a redo of some of this stuff coming up in the future. But again, I want to make sure that I put an economical order together so that my per unit cost shipping is not outrageous. In the next video, I want to get back to the EEPROMs again. And now I need to focus on how I can read that data off the serial EEPROM and get it set up in RAM so that I can use it to drive the control logic. And that'll be the focus of the next video. I'm not sure I'm going to get all the way through that. I will give it a good effort, but it may end up being a two-part. We'll see you soon.